So, good evening, everyone. Am I audible to you?
Yes, sir.
So, good evening, everyone. Am I audible to you? Hello.
Yes, sir.
Am I audible to you?
Yes, yes.
Okay. So, let's start our today's class. So, we will continue our discussion on cloud computing, what we have started in our last class. Today, we will discuss on a topic which is very much relevant in present context of our daily life, from the daily life to the automation industry. That is sensor cloud. So what we have seen, or what we are seeing in these days, that it's a world of sensor, right? And there are enormous number as well as the varieties of sensor are available around us. So the very popular kind of sensor network or the sensor managing system, I can say, that is used by the several automation industry as well as the different kind of application, that is the wireless sensor networks. So here what we have, that is we have set of sensors which sense or accumulates the information about the environment, that may be the temperature of the furnace or the ambient, anything else, it may be defined kind of the physical parameter. And uh, and what happened is that, so after sensing, there is a back end, and some intelligence or decision making system is there, which takes some call or activate the actuator. Okay, so we have a sensor and set of actuators. In between, there should be either physically or logically a decision support system or a intelligent system which takes something. That is kind of the sensor cloud. But why is that sensor cloud is different from the wireless sensor network? I want to give you a clear picture about that. What is the main difference between the presently available wireless sensor network and the sensor cloud? So let's move forward. So what we try to say is that there is a amalgamation, or there is a there is a need to, why we need to integrate our sensor with cloud, the cloud infrastructure. And having a cloud infrastructure or a cloud of sensor, which this kind of sensor clouds has a property of emulating the properties of cloud. What I try to say is that this cloud of sensor or the sensor cloud is a concept which has some physical sensor as well as some decision making system. We will learn this in detail. So that's why this sensor cloud is very popular. This type of ubiquitous sensor system, or rather say, that is very popular for the industry 4.0. Now, so that we already we are more or less aware about that our present scenario is present sensor monitoring or sensor management system is based on the wireless sensor network. And I believe that you have more or less it is known to you. So it is seamlessly couples the physical environment with the digital one. That is the basic principle of the wireless sensor network. There is a wireless sensor network and which has different sensor nodes. You can see. So these are the sensor nodes. These are the different sensor nodes. Or sometimes someone, I mean, some people are also, I mean, calls this as a modes also. So these collect the information and digitize the information, the physical data, or the analog data. Then push this analog data through the gateway. This is the gateway to the different systems like mobile or maybe in the internet, but and maybe on the computer. Fine. So this is the main basic principle of the sensor wireless sensor networks. So but there is some typical limitation. So these things, so what are the limitation of these sensor networks? So then only if I understand that, then only we can move forward to the sensor cloud. So we can so before going to anything, before going to develop or understand any technology, we have to understand that what are the available in the past, what are the limitation of that. So that's why we move forward to the new technology. So let's start with the limitation of the sensor network. So the typical limitation in the sensor network that are that is kind of, it is very challenging to scale the sensory networks to large sizes. That is suddenly needed for I mean for scale down or maybe some scale up. So for kind of example, if there is a loss for industry, so they want to scale down some sensors, so they they can't do that by using this kind of wireless sensor network because they are already available. And some industry, if you want to scale up, so they have to, I mean, so for example, you have there is a industry which is 20 years back they have installed the wireless sensor network. So if it is that industry want to scale up, so what that industry has to do is that they have to replace all the sensors, node sensors, physical sensor, all these protocols, all these the system they have to replace because the technology has upgraded. So that is the major challenge of the wireless sensor networks. Not only this, the proprietary vendor specific design is in this kind of wireless sensor network make it very difficult to be interconnected with other sensor network. Fine, because all the companies available in the market, they have own protocols, they have own management system. So if you want to interconnect your system with sensor networks with another kind of vendors, so you can't do that using this wireless sensor network. So there is another problem, that is interoperability of the sensor. That is the another problem of this kind of wireless sensor network. Fine. And also you can see there's insufficient computational and storage resources to handle the large scale application. And you can see there is a this kind of sensor used for fixed and specific application that cannot be easily changed once deployed. Fine. So these are the main limitation of the sensor. So now we will step by step move forward to the sensor cloud. So first of all, I want to say is that don't I mean think that the sensor cloud means you have a sensor data and you are uploading to the cloud. That is not true. That is totally I mean wrong. the sensor cloud is different thing. I will explain. But first of all, I want to clear that thing, that is sensor cloud is not kind of thing that you have a sensor data, and I mean, for example, you have analog data that is converted to a digital data, and you have a sensor cloud. And what you are I mean, you may have you might have think that the I have a sensor data and I want to upload that in some cloud, so that is the sensor cloud. No, that is wrong. So coming to the this slide, so you can see, so we have a sensor network, and we have a several kind of application in nowadays, maybe computing platform, different kind of application, cloud storage, social networks, codes, services, cloud economics, lots many more things are with them. But so we should have to bridge between these sensor networks and the user. So in between them something is missing, so that missing item is the sensor cloud. So why we need to integrate the sensor with cloud? Let's see step by step. So it acquisition of data feeds, I mean, so it's actually easily you can feed the data from numerous body area. I mean, say for example, if you go for the healthcare example, so it can take the very numerous amount of data. So if you want to monitor the water quality of any, I mean, any steel industry, so you can do that. So it's a kind of wide varieties of sensors are there, and you can integrate all the sensor, and you can acquisition of data, you can take the data from it and you can upload the cloud. That is the first thing. But where is the difference, I will come. So you can you can do the real time processing of this heterogeneous data. So this is very much important. So you can do you can process that different kind of this. For example, you have a temperature T, so or you may have some humidity percent, relative humidity, or you may have some pressure, okay, or you may have some any other flow. So these all are the sensor, these are the physical sensor. So you take the data from it. Now these data are the heterogeneous, different kind of sensory data. So what you have to do is that you have to, I mean, this data will be, there will be in simple words. This is the, so let's describe this thing in some very simple word. That is, you have first, so if I try to explain it in very simple words, this will be something like this. So in our WSN, that is wireless sensor networks, what we have, so if you you consider this is a boundary wall of a industry and you have different sensor nodes, okay, and based on the battery life or any performance, so some of the sensor node can be considered cluster head. So what it will do, these are the sensor 1, sensor 2, sensor 3, sensor 4 and so on. So all these sensor will communicate to this cluster head. I mean, that give the data. They will send the data to the cluster, and this cluster head will give the data to the gateway, and the gateway will give the data to the internet or the user, or the graphical user interface. That is the concept for the WSN. Now, if I come to the sensor cloud, so in the sensor cloud, what happens is that you have a data source, I mean the physical sensor, what can I do this is that and let us consider some different factories of a single owner. So this is one factory, this is another factory, and this is also another factory. So this factory number 1, factory number 2, I mean also these are located in different locations around the globe or maybe in India. And in this factory there are different physical sensors are there. So different physical sensors inside these factories. So these are the physical sensors. So see, this sensor cloud is a kind of very good philosophy. I mean thinking. So these are the physical sensors. Fine. Now, so you remember think that okay, so there may be some cloud over here, and cloud may be AWS or anything else. So there's some cloud. So this is AWS or any kind of cloud. So cloud service platform, and you also know that that should be the graphical user interface. This may be different kind of graph, it may be pie chart, I mean analytical term. So in between them, so what you think that this sensor thing, there may be some gateway as it was in case of WSN gateway. So what you can think that the sensor data will go to the gateway and that will upload it to the AWS, and you can see the different data in graphical interpretation. So this is the there the sensor clouds tell you that wrong. You are totally wrong, because sensor clouds is a concept which actually implement the very interesting philosophy that is called the virtual sensor. That is the main difference between the wireless sensor networks and the sensor cloud. So what is the virtual sensor virtual sensor? So virtual sensor is a kind of concept that gives you the decision. How? So for example, this is virtual sensor 1, virtual sensor 2, virtual sensor 3. So it may be taking the all the data from here. It may be taking the data from here and so on. Now see, there may be some temperature sensor, there may be some pressure sensor, there may be some flow sensor, there may be some any other kind of sensor. So what the virtual sensor is, I mean, do is that it will give you a decision. Say for example, if I want to ask you the what is the, I mean for example, take a very easy example, then we'll may go to the industry. So if I ask you what is the traffic condition for the particular location, so in that case, what we will think that is something like that. The what is there any, so if there is a traffic something like this. So suppose you are a tourist. So what do you think the traffic means? Is there any congestion or not? No, that is not the traffic system. So suppose you are a tourist and you want to know the what is the temperature. Okay, this is a meteorological data. What is the humidity? And obviously congestion, traffic congestion should be there. And is there any probability for any procession? So all these things, that is defined the what is the traffic condition. So the virtual sensor is tell you the what this is the virtual sensor, and all these things are the physical sensor. Because for the traffic you have to you have to install a camera image, the CCTV, like that kind of system. Temperature sensor you need, humidity sensor you need, and probability. This is also kind of statistical analysis. Don't forget about these things right now. So the virtual sensor is something like that will give you the solution for a big problem. That will give you the understanding for a particular area, and that is the combination of different physical sensor, the data which is coming from the different physical sensor. So that is that is how the virtual sensor is very important in the industry as well as in the industry 4.0. That is the concept what on basis of which the sensor cloud is forms. So similarly, if you have lots of sensors, so you need a virtual sensor group also. So this is the higher stage of the single sensor, the virtual sensor groups. Maybe between 2 sensor, 4 sensor, in number of sensors. So there may be some virtual sensor group. And the output of this virtual sensor group will go to the gateway. And so they are actually making the decision. So what is the traffic condition? Not only this, for another possibility or another concept is there. Suppose, for example, in a factory, you want to you want to see the temperature of. So, for example, here is a plant one. This is the factory one, and this is the plant one, and this is the plant two. So you want to see the temperature of the plant one. So what you think that the all at the same time all the sensor will be on, but that will reduce your battery life, that will reduce your lifetime of the sensor. So if the whatever the people are there as the managing system, they will ask the through the sensor cloud, and that will come to the gateway, and this virtual sensor will decide now, okay, the someone is want to take the information of the what is the temperature of this plant one for a particular person. So now this virtual sensor will give to the information to this virtual sensor one that please turn on this sensor and tell me the temperature. So see, there is not only the decision making system, there is a use of use of saving the battery life as well as the increase the performance of the sensor as well as the lifetime of the sensor. So there is how this sensor cloud is beneficial for our in our industry. So let's talk about some theoretical basics. So what is sensor cloud computing? An infrastructure that allows truly pervasive computation using sensors as interface between physical and cyber worlds. In addition, the data compute clusters as the cyber backbone and the internet as the communication medium. So all these things are amalgamated in this sensor cloud. So that's why I'm very beginning I told you the sensor cloud is a philosophy. So I don't want to okay, so let's so sensor cloud enables user to easily collect, access, process, visualize. Visualize means you will get data For time, if you want to see that this is time and this is the temperature, and you want to see the graph of the temperature over time, so you can visualize it. It supports complete sensor data life cycle from data collection to the backend decision support system. So it allows sharing of sensor resources by different user and the application, because these are all the open source kind of things, because you have particular thing that is this is the kind of the coding. So you are doing a coding for the virtual sensor, so that is versatile. You can use it anywhere in the globe. And it enables sensor devices to handle the specialized processing task. Okay. So this is the overview of sensor cloud framework. Here you can see, as I told you, that is, and you are the user. So there is two important things: sensor cloud proxy and sensor network proxy. Okay. So these are the components of the sensor cloud, and these things. This part is the GUI application part, and this is the communication part, satellite connection. Some networks connectivity is required for this. Now these are a kind of theory part. uh, you may have to you may or may not interested in it. So their main two part, the sensor network proxy and the sensor cloud proxy is there. So here is some information about that. You can just read it. That is, this is the interface between sensor cloud proxy, the interface between sensor resources and the cloud fabric. And on the other hand, the sensor network proxy is the direct connection to the cloud, and this component provides the connection. So this is once again the overview of the cloud infrastructure. So these are the existing studies. So what you can see is that the data processing, these are the things that are available right now. This is the WSN kind of things. But here you can see that these are virtual sensor groups which can directly communicate with the various sensor, that is various kinds of physical sensor, and these virtual sensor groups can monitor, can control this physical sensor. At the same time, they can upload the data at the web browser, and that web browser or the in the cloud can from using that cloud you can observe or monitor the data. So I have also write down some points for the virtual sensor. So virtual sensor is an evaluation of a physical sensor that obtains its data from underlying physical sensor. The virtual sensor provides a customized view to user using distribution and location transparency. In wireless sensor networks, in wireless sensor, the hardware is barely able that is barely able to run multiple tasks at a time, and difficult to run on multiple VMs, such as the traditional cloud computing. To overcome this problem, virtual sensors act as an image in the software of the corresponding physical sensors. Okay, this is a kind of ghost. You can understand in this way also. The virtual sensor contains metadata about the physical sensor and the user currently holding that virtual sensor. You may have, you may have find interesting with the fact that you may in some days, for not in next 10 to 20 years in future, if you consider the 50 40 to 50, say for example to 2060 2070, in that time you may have heard that you will understand or see that there is no physical sensor, only virtual sensor is working. Because for example, for some data, so what it will do is that, so you have a physical sensor 1, physical sensor 2, physical sensor 3, So let's so if you have the actually the virtual sensor is finding the associativeness between these physical sensor. So what is the relation? For example, the resistance, you know, this is a physical parameter. So that may be changed due to the temperature, ambient temperature change. That may change due to the different gases that is present in the environment. That may be changed due to the change in sensor can measure the resistance to to tell that okay this right now the ambient temperature is this. So gas sensor can change the can measure by measuring a resistance, can tell that okay this gas is present in this atmosphere. So similarly, humidity sensor by measuring the resistance, it can tell that okay, this is the humidity of your environment. So all these things are related to the resistance. So what if a physical sensor can find the relation? Relation means the temperature. If this temperature, okay, this change. If you have a x equal to, for example, I am giving you for thermistor or the or a thermocouple, that may be there is a non-linear equation is there, alpha t n and dot dot dot. So there is a relation, and similarly gas sensor there is also relation, and humidity sensor there is relation. So if the virtual sensor, so what it will do, it will measure only resistance and tell you what is temperature, what is the gas in the environment, and what is the humidity at the environment. So see, so you don't need all these three sensors. By using a visual sensor, you can do you can get the data for temperature, gas, and the relative humidity. So in future you may see that the virtual sensor is actually replaced by the physical sensor. The virtual sensor is actually trying to find out the associativeness between the different physical sensor, and there is a artificial neural network is there. By using that, or by using machine learning, that can tell you the exact data. Maybe there is some error should be there because it is not that matched, but in future you can see that they can exactly tell you the data which can by that is equal to the data which can be by using a physical sensor. Got my point? So that is the beauty of the virtual sensor. So here I also give you some example like this. So here we have end user, here we have the sensor owner. So I have, say for example, I have some physical sensor, so I can use it. So that is the versatile and that is the open. So that's why it's kind of open sourcing thing, as I told you. And there is some sensor cloud admin. So this all the virtual sensor is connected in the sensor cloud infrastructure, and that is the very easy kind to this is very easy to understand. And no, just to just for your information, this virtual sensor configuration may be one to many, many to one, and many to many. Means suppose one point is there and another point is there. So a point one. So here you can see. So this is virtual sensor. So many to many means. So these are the physical sensor. So this physical sensor can communicate with any sensor. It may be this virtual sensor, or this physical sensor can communicate with this one or this one. So this is called the many to many. Similarly, you can see the one to many, that is this particular virtual sensor can this one can communicate with this one, this one, this one. So one to many. So many to one you can easily understand. This is a kind of theoretical things I can tell you. So this is all about your virtues. So similarly, so there is an example that, so suppose you want to find out the environmental condition is safe in the wildlife, or maybe in automation industry or any industry. So that is the condition, that is the complex question that can be asked to the sensor cloud, and depending upon the infrastructure, the sensor cloud will give you the answer. So in summary, the sensor cloud infrastructure visualize sensors and provide the management mechanism for the visualized sensor. Sensor cloud infrastructure enables end user to create virtual sensor groups dynamically by selecting the template of virtual sensors or virtual sensor groups with IT resources. Okay. Next point, that is sensor cloud infrastructure focuses on sensors management system and sensor data management. The last point is sensor clouds aims to take burden of deploying and managing the network away from the user by acting as a mediator between the user and the sensor networks and providing the sensing as a service. So here is a sensing is also as a service. So if I so this is kind of theoretical things what is the about the sensor cloud. Now if I give you the very quick practical example of this what is sensor cloud. So for example, you have a sensor, physical sensor DHT. It is used for measuring the humidity and the temperature. This is the physical sensor. Now from here, for example, you have a Arduino Uno, or maybe any kind another Raspberry Pi, any other kind of microcontroller. So this is a microcontroller. So what you'll do, it will take the data, and then you have one wireless module. It may be Wi-Fi module, maybe Bluetooth module. So what is this? This is wireless module. Then you have gateway. Then you have one cloud. That cloud may be AWS or ThinkSpeak. That is very popular for the students, because it is free. So you have cloud. So whatever the data you are getting from this sensor, that is controlled by the Arduino, and wireless module will give the data. So here there is a virtual sensor is there. So you can write the different program over here to control these things. So in between them, obviously there is a laptop, and by using laptop you can program the Arduino and the virtual sensor and virtual sensor groups. Then by using the wireless module, you can upload the data to the gateway, and similarly in the using the cloud, you can see it from the remote location. Fine. So this is all about our sensor cloud. I will also show you a video on that, how to upload the sensor data, and whatever I told you over here, I will show you a video on this in practical example. Now I will move to the next part of our discussion, that is the sensor Okay. So that is the basic of networking, communication protocol, sensor networks, machine to machine communication. So today I will just give you the basic understanding of the networking. So let's start with that very quickly. So you know that the building blocks of our networks is as follows. That is, we have some networks, we have application layer, and we have a device layer. This is very easy and well-known architecture. This is a very basic things of our architecture. Now, let's start with some basic things about our network. So in networking model, there are two main things are there. Local area network, LAN, and wide area network, WAN. So in local area network, you have IP, that is the logical address of any networking item like laptop, computer, mobile, printer. You have switch, you have subnet. Then on the WN, you have the firewall, you have the DMG. I'll tell you what is this. Port forwarding and NAT. In between this, you have the router, and the IP address of the router is the gateway. Or I mean, sorry, that is also sometimes called the gateway. Now let's start with the LAN, that is local area network, with very good example of a school. So for example, you have a LAN network, and in LAN network you have computer, PC, you have laptop, you have printer, and another thing you have, that is switch, and this is LAN, local area. So now in the school, similarly, if you consider a school or an institute, so you have different sections. Class 10, class 11, class 12, and there are several peoples are there. They are the student, and there is a coordinator of this all this class. Some may have peon is there, and this is the gate of the school, and there is a security guard. Now see, if I write the so IP is kind of, it's a logical address of a device in this network. So it may be write something like 192.168.0.1, and similarly it has also 192.168.0.1. Fine. Now what is switch? Switch connects device within the same network. So as I told you, this in this LAN is local area network. This is the one network. So this switch actually connects the devices within a same network. For example, you want to print something from your laptop. So by using switch, you can send the so for example, you want to print a laptop which is not in your office, somewhere, far from your office. So you just give a command for a print, but now switch will determine the which. So what is the printer? So by says the switch actually know the printer address is this. So that command will be passed to the printer and you can able to print. So switch connects the device within the same networks. So also you want to communicate, so you have a laptop, you want to communicate with the PC. So you can do that by using the switch. Now come to the another component that is called the router. What is router? So router is a networking device that forwards data packets between different computer networks. So now I come to the school example. So here IP is a roll number of the of this particular of any student, and switch is the peon, and router is the main security guard. This one. So now I'll describe it. So see, the all the student has some roll number, unique roll number. For example, S1, this is school 1, S1 dot class X dot some 1 dot 1. So this is the roll number of one student. So they are in the school 1. So this is the IP address. Fine. Now what is switch? So if this student want to this student from the class 10 want to talk with the class 11. So what he'll do? You will go to the peon. Want to talk with the one with my I want to talk with a student which is from class 11. So now that peon will give the permission to this student such that this student can talk with the student of class 11. So that's why you can understand the same thing can be done using a switch. Now what is router? Router, as I told you, there is a different network. So one student want to talk with the another school. Say for example, there is a school 2. So this student want to talk with the school 2. So the student of a school 2. So what you will do? You will go to the main security guard, and the main security guard may or may not be allowed depending upon the rules of the school. And after that only this particular student can communicate with the student of school 2. So that is the router. Fine. On my point. Now there is another thing that is called the subnet. Subnet defines the local area network range. So how that will happen? So after router you may think that there is the internet. So you may think that what is subnet? You may have I may have seen that this kind of things 255.255.00, whether the IP address may be 192.168.10.20. or maybe this is for a laptop 1, or maybe some 192.168.1.2. So subnet marks, although it looks like a IP address, but it's a flags. It's defined you the range of the IP address. So you can see that this 192.168 defined this local area network. So that's why 2555 and 255, and other 2 points maybe different for different devices. 10, 20, 1, 2. That maybe this is for laptop 1, this is for printer. So these are the different for different devices. Fine. So you can understand what is subnet. So for example, if you go to the this school example, so I have a student from class 10, and he has the roll number something looks like this, and I have a student from class 11, he has a roll number something looks like this. So what is the subnet for this? So you can see that the the flag which is common in between two students, that is only S2. So what is the flag? What is the subnet of this? That will be 255.0.0.0. Fine. So this is the subnet. Now come to the gateway. So gateway is the IP address of the router. So now let's take this thing and understand the next part, that is WAN. So we have understand the LAN part. Now we are trying to understand the WAN part. So router, gateway is what? Gateway is the IP address of the router. Now you have the router, and if you see the WAN part, so this is your WAN. This is wide area network, and in wide area network there may be some PC, laptop, and most of the main thing is the internet. These are the devices. Okay, and thing is that, so main thing is that, say for example, if this device want to communicate with this particular device, they can't, because there may be a security option is there. So that is not benefit for us. That is not secure for us. So most often this ad hoc request is blocked by something that is called the firewall. Now the router along with this firewall will decide who will what what the will decide how these devices in this LAN can communicate with the WA. Now let's start with the NAT. So router has some protocols. So these are the NAT, network address translation. It has firewall. So these are the components of the integrated router system. It has DMG, it has port forwarding. So what is network? NAT? NAT network address translation, or NAT, is a method of remapping an IP address while they are in the transit across a traffic writing device. That means, in simple words, this IP address, by using the NAT, this IP address is camouflaged and exposed to the internet because there may be a security risk. So by using NAT, what the router does, that is, it convert or translate the it will translate the address, that is the IP address in the local network, to different kind of address, and that is that then it will expose to the internet. Now coming to the firewall part, as I told you, there is a set of passive rules are there in the firewall to protect the network from unauthorized access. Okay. Now come to the DMZ. DMZ or demilitarized zone is a sub network that contains and exposes a device to an untrusted network such as internet. For example, if I come to this once again this school, for example, some parents from school 2 want to talk with the student from class 10. So what it will do is that it will come to the security guard first. Fine. Now this security guard will decide that before deciding that, what you will do, if there is an option, there is reception. So this security guard will send to the reception person, and that reception person will decide that whether these parents will communicate with the student or not. Similarly, in the firewall there is a DMZ or the demilitarized zone, where this is a subnet that contains and expose a device to an untrusted networks, because these all the device or in the internet, these are the untrusted networks and to this LAN network. Okay. So if some device try to communicate with the device in the LAN, so what it will do, DMZ, by using this DMZ protocol, so it will actually sit here, and whatever the device available in this the DMZ area, I mean, if there is some device are there, maybe some laptop or computer, they can directly talk with this device, but not with this particular device which are seated in the LAN network. The last thing, that is the port forwarding. Port forwarding is kind of forwarding protocol. That means it redirects a communication request from one address and port number communication to another, while the packet are transversing a network gateway. What that is mean, in simple word, when you click any address, any address to the in your web browser, so automatically by default that will hit to the port number 80. So there is some protocol, there is some coding is there. If some devices from the WAN directly connects to the is connect, so for example, you have a device in the LAN and you have a device, and there is a device in the WAN. So this device want to talk with the LAN. So there is a port forwarding means, if this device offers the port that is, for example, 80, so we can directly talk with this particular device. If this is not port 80, so that means the firewall will block the, or this router will block the communication. Fine. Similarly, you may there is a fact, for your kind information, the Oracle server may use 1532 port, and there is another server is there that they use the 8080 port. So these are the kind of port forwarding technique. That means if the port matches between the device in the WAN and the device in the LAN, then the device can communicate with each other. So these are all about the basic of our networking, and I think this concept is very easy and we are using our daily life. So this same thing also used in the industry. So let's, if you have any question you can ask me please, and otherwise I will go to the video that will show you how to make a sensor cloud by using the components what I have already discussed. Any question? Okay, I think I am going to the video.
Guys, welcome to Electronics Innovation.
Hey guys, welcome to Electronics Innovation. In this tutorial, we are going to see how to post data to the Amazon Web Services. In this task, we will interface DHT11 with the ESP32 and post the temperature and humidity data to the Amazon Web Services using Arduino IDE. So let's begin this tutorial. Requirements are ESP32, DHT11 or DHT22 and post the temperature and humidity data to the innovation. In this tutorial, we are going to see how to post welcome to Electronics Innovation. In this tutorial, We are going to see how to
Hello, is my screen is visible to you?
Yes, sir. Screen is visible, but video is not visible.
Yeah, this I don't know. Last day I also uh, play a video, but today what happened?
Yes, sir. Now it is okay.
Is it audible?
No, sir.
No, sir.
In this task, we will interface DHT11 with the ESP32 and post the temperature and humidity data to the Amazon Web Services using Arduino IDE. So let's begin this tutorial. Innovation. In this tutorial, we are going to see how to post data to the Amazon Web Services. In this task, we will interface DHT11 with the ESP32 and post the temperature and humidity data to the Amazon Web Services using Arduino IDE. So let's begin this tutorial. Requirements are ESP32, DHT11 or DHT22, an account in Amazon Web Services, and an Arduino IDE installed in your computer. So, total this process includes the 5 steps. One is installing required libraries and creating. A second thing is creating a thing in AWS, generating a certificate and attaching a policy to it. And third is modification in the Arduino sketch according to the thing. And fourth is a testing and subscription of a thing on AWS. Five is uploading code to the ESP32 and live demo of data logging. So let's begin this first step, installing required libraries. So for this we have to install 2 libraries. One is Hornbill examples and another is DHT11. So go to the links which I have given in the description and download the following. here we got the Hornbill examples master downloaded, and we need to download this DHT sensor library also. So clone or download zip, and okay, and here you will get your file downloaded. So copy these two files in the one folder and extract them. These are the libraries, and DHT sensor library, this is the library we got, and rename it as DHT, and go get inside of that, and we need to delete these two files. You just delete this, we don't require them, and come back and Hornbill example master, and go to the Arduino ESP32 which you are going to use for the data posting, and copy this file AWS IoT, and go to the Arduino libraries. These libraries needs to be added there, so just simply paste it over here. I have already pasted it. Here you can see AWS IoT. Yeah. So this is the library we got, and these are the library files that have downloaded by the Hornbill, and we need to add the DHT also. So go to the same folder and copy this, and go to the Arduino libraries and paste it over here. I have already pasted. These are the library files. We have completed the first part, and let's move to the second part. The second one is creating a thing in AWS, generating a certificate and attaching a policy to it. And for that, you need to log into your AWS account. So first go to the Google and click, just type AWS and you will get this link, and sign into the console. I already signed in, and you just type IoT, and IoT core will be displayed on the third. So you just click on that, and that will redirect to you the main page of the AWS IoT core, and AWS IoT is here, and go to the manage and register a thing, create a single thing, give a thing name, whatever you want to give you can give here. I'm giving DHT11_demo. That's it, and come down. Next, and here we need to create a certificate also. I successfully created a certificate, and these three are the certificates which are used to communicate with the AWS server for the authentication. So you just download these two. One is certificate for this thing and the private key. So download this also, and you also need to download the root CA for AWS IoT. So there are three keys, but we will download only one, that is Amazon root CA1. So this is the certificate, and you just copy this and open MS Word file. Paste this certificate data in that and save as. Amazon root CA1. And here we need to activate it, and done. Click on done. Here you have successfully created one thing and certificate. Go to the policies, and here we need to create a policy also. So click on the create and give a name to your policy. So here I am giving a policy underscore DHTW1. And action, I'm mentioning a star. A star means it will allow all. So you just replace both fields as with a star and allow it, and then create a policy. And you have successfully created the policy here. We need to attach this policy to the previous certificate. So go to the certificate and click on these three dots and attach policy. Check this policy underscore DHT11 and attach. You have successfully attached your policy. We have also completed the second part, and let's move to third one, modification in the Arduino sketch according to the thing. So whatever the thing you have created, we need to perform some modification to that thing. So go to the AWS IoT library in the Arduino IDE and go to the src files and click on the AWS IoT certificate.c. And here we need to do some modification regarding the certificates of the your thing. So these three fields we need to update. And these three are the certificates that we got for the authentication. And open this certificate.pem.crt with the Microsoft Word. And we need to do some modifications here in this. So you just add a \n / and add that to the all lines. Copy this and go to the AWS IoT certificates, and this is the PEMCRT. Replace it. And come back to here and open this private key with the MS Word Office only. Open with more options, same thing which we have done, and open this AWS IoT certificate.c and paste it over here. This is the private PM key, right? So we need to paste it here. That is the root CS certificate. And go to the same folder again and open this Amazon root CA1 docx and perform the same thing. And save it. And let's edit this sketch. So according to your sketch, we need to perform some modification, and in the meanwhile I will explain the code also. So here we are including the Wi-Fi.h, DHT.h and AWS IoT.h, and DHT pin is 33. I'm going to connect my DHT11 to the 33 pin of ESP32, and DHT type is DHT11. And if you want to use DHT22, you just simply replace here DHT11 with the DHT22. That's it. And these are the Wi-Fi credentials you have to provide, and provide your Wi-Fi SSID and password here. And these three are the main things you need to take care of while you are connecting your device to the Amazon Web Services. So the first thing is a client ID. This client ID is a thing unique ID. This should be the unique among all things associated with your AWS account. And here I am named my client ID as temp_humidity. And one more thing is MQTT topic here. So we are using MQTT protocol to transfer data from our device to the AWS. So this MQTT topic we need to get from the website, and go to the things and click on that thing you have registered and go to the interact button and this update to this thing shadow. So copy this text. This is the link and this is the MQTT topic for your thing, and paste it over here. That's it. And this is the AWS host. This host also you need to get from the your AWS website only. So just go to the website and you can find it in this field. So copy this and paste it over there. And here we have some object creations. And coming to the wide setup, this is the 9600 baud rate for serial monitor. And here I have given some comments to know what is happening inside of the DHT22, and initializing Wi-Fi and connecting to a Wi-Fi SSID. This Wi-Fi SSID is whatever you have given above. That is, I have given electronics innovation, and this Wi-Fi dot begin will connect your thing to the Wi-Fi, and after successful connection, and it will initialize the DHT11, and it will be done. After that, initializing connection to the AWS, and here AWS host and client ID. With these things we are able to initialize connection, and these are the fields to take data from the DHT. Temperature and humidity is not a number, and it will show reading filed else, and it will make a string whatever data which have taken, and this string data we are going to post to the AWS. And after getting the payload, we are just hitting MQTT topic with the payload, and we are waiting for 1 second to post the data. We have completed the third part also. Let's move to the fourth part, that is testing or subscription of a thing on AWS. And go to the website again and go back. Go to this test bar, and here you need to subscribe your MQTT topic. So go to your code and copy that MQTT topic which we have placed there, and copy from there, paste over here, and subscribe to the topic. And before subscribing, you just check these fields as it is and subscribe. And we have done the fourth part also. Let's move to the final part, that is uploading code to the ESP32 and live demo of data logging. Connect the circuit as shown and connect the data pin to the IO33. And this is the ESP32 which I am going to use. And this is the DHT11 sensor that I am using here. And I'm taking a minute to connect to it. Yeah, connection has been done. And connect your micro USB to the ESP32 module.
So as I told you, see this one is the DHT sensor, humidity sensor, and this one is the Wi-Fi module that is connected with the Arduino, and which can be controlled by a computer. And by using the source, I mean virtual group, you can also use that thing.
And connect the another end of the data cable to your PC. And open your Arduino IDE. Follow the same instruction. Let's upload it. And first it will compile the sketch, and then it will create a hex file, and then it will upload. the sketch to there. So while uploading, when you got this connecting, to press this boot button once. After that, uploading will be initiated. Let know IDE, follow the same instruction. Let's upload it. And first it will compile the sketch, and then it will create a hex file, and then it will upload the sketch to there. So while uploading, when you got this connecting, you need to press this boot button once. After that, the uploading will be initiated. And here it is uploading. It will take a few seconds to get it upload. Here we got done uploading, and now we open the serial monitor. Initializing thing temp underscore humidity underscore DHT0 and initializing Wi-Fi and connected to the electronics innovation. Yeah, the connection made success, and initializing connection to the AWS, and this is also done. My current room temperature is 29 degrees Celsius and humidity is 77%, and the same data will be transferred to the server. So go to the server, Amazon Web Services, and here we are getting the data, same data. This is how we are transferring this DHT11 data to the AWS, and I think this is a little bit a lengthy process, but we need to follow. Yeah, thank you for watching.
Hello. I think you enjoyed the video. It's hello. I think you enjoyed the video. So that's it for the today's class. So we will meet again in this Sunday as per scheduled class. Thank you and good night.
Okay, sir. Thank you.
Okay, sir.
Good night, sir.
Good night.